Beautiful day to do math. All right, here we go. I think we're taping. All right. So, what's a matrix? This is silly. Okay? Just write this down. It can't be discovered. It just has to be defined. We can't Common Core this crap out. Just a rectangular array. And in this case, I'm sure you could put something else than numbers in a matrix. I've never really seen it. For math, we're going to have a rectangular array of numbers, and we're going to do math with those. We know what a square is. Equal sides all the way around. Which, this is kind of out of order. A matrix has dimensions, and the dimensions are rows by columns. And that is important order-wise that you memorize. When we label the dimensions of a matrix, somebody decided rows go first, columns go second. I'm just telling you, I'm the informant. I learned that. I never learned a reason why. Whoever put matrices together, the matrix math, this was the decision made. So, of course, going back to what's a square matrix, the amount of rows equals the amount of columns. Very simple. Just like sides all equal. Length and width is equal. So you'd have a 2 by 2, 3 by 3, 4 by 4, and so on forever. Let's take a break for a second. I need to breathe. Start that on. Elements are just the numbers in the matrix. And that'll be solidified in the next little organized set of notes. I'm going to leave you alone for a while, but then after I'm going to pick groups and you're going to answer questions. I think I'm going to wait till we get to matrix multiplication. Okay, so I said rows by columns. What are the dimensions of this first matrix then? Everyone say it. 1, 2, 3, go. 2 rows by 3 columns. Someone's a little late over there. 2 by 3. 2 rows by 3 columns. Then just to move on, what element, that means what specific number in A is in this position? What's the 2 represent? The row. What's the 3 represent? The column. So who's in row 2, column 3? What number? Ooh, 5, 4, 1. Hike! I just got so a bunch of different answers. It's actually -4. -4 is in row 2, column 3. So who is A12? That one's -1. Trying to erase that. Because that's in row 1, column 2. So that's just how you denote where certain things are. Now, you did what? You flunked this time?
No, I got 100.
Oh, 100. Okay, I thought you said flunked. No. Okay, now, matrix addition. This is ridiculous. I know that we're in Algebra 2, and actually, if you're not, everyone I bet you knows this. Who do you think you add A to? E. You just add A plus E because they're in the first row, first column, and you get a number. Mathematicians like to put letters to make this like a formula. Who do you add B to? BFF. Who do you add C to? And then who do you add D to? Come on. So this is not anything. And then I'm not even doing subtracting, not going to insult your intelligence. You just subtract the equal elements. Or what you could do is add the opposite of all these elements, which leads to the bottom of this page, what a scalar is. I'll put what a scalar is there. It's a multiplier, really, out in front of a matrix. I don't really know. Someone will put better words than that. It's not really about that. It's about how to do the math. So what I did is I put plus a -1, and then I distributed a -1 into the other matrix. Then what you could do is add the opposite of E to A, and then add the opposite of F, add the opposite of G, add the opposite of H to each of its correlating components. I'm just going to add the first one. It's not really rocket science. I'm going to say this online. This is so right in the middle, so random. You don't. I said this in all the other hours. I forgot. I'll tell you a little story. Put it on the internet for no one to listen to. The reason we're doing this is because our last chapter was about codes and coding numbers, and the numbers actually mean something, and driver's license, that actually has meaning in that number. And I got whose license in here. Whose license did I write down? Right here? Yeah, okay. Then it spurred in my mind, I know what matrices have been used for. And then I talked to the other teacher, and then I talked about something else, and then she took it to another level, and we really worked together about this whole unit, and I think made up something interesting. So in history, actually, I believe, at least I know in World War II, to send a message to your allies, what you want to have happen in another country, they'd have to use radio. And of course, radio can be intercepted, right? So they'd have to encrypt the message and then have a decryption code on the other end to get this encrypted message and then decrypt it so they know what the message was supposed to be. That can be done using matrices. And as a matter of fact, anyone ever hear of Enigma? I thought I brought that word up before. Who had it? Oh, okay. I don't remember. I just had my hand up. The Germans. Okay, the enemies, the evil empire in World War II used Enigma, and there's a true story about what Enigma did was encrypt messages, and then they had a machine that decrypted it on the other end. We broke the code. We broke the code, and that was one of the main reasons why we won the war, at least won the war quicker. It was through mathematicians actually encrypting or figuring out what the code was of Enigma and so on and so on and so forth. So we're going to delve into that. You're actually going to find out about that historical element. And then what we're going to do is going to do our own encrypting and decrypting using matrix math. Doesn't that sound like fun? Oh, he fumbled. He's so excited he dropped everything. He's like, oh my gosh. All right, so anyway, that's why we're doing what we're doing. Okay, so I'm sure you can add numbers. All right, the next one. Who's negative 4 add to? Silence. Who's negative 4 add to? Sure. Who's 0 add to? What? Who does 10 add to? Nobody. See, this is in row 1, column 3. There is no row 1, column 3 number. So this is called not possible. I don't think you really should say no solution. This is not possible. The reason is what's called a dimension mismatch. The only reason I'm writing this, I think I have 84s and 83s in my head. When we go to the calculator graphing and do some matrix math with that, I think that's the message you get. I think it says dimension mismatch and then some sort of other error. Okay, just so you know what a dimension mismatch means. Okay, so back to this one. Continuing with the notes on these next ones, which I really barely have to bother you. Scalar multiplication is done just by distribution. This is all Mickey Mouse stuff right now. Those that had Algebra 2, you don't even probably need me for this. You may barely need me for the matrix multiplication part, though. That's different, not this kind. So basically, this is just distributes. You can do that on your own. And then this is distribute all the way through. Then add the 2 remaining components. You go ahead and do that right now. I'll get the answers, and then we'll move on to what you really need me for. All right, just because of time, I'm going to go ahead and reveal this next answer. And if you're working, just kind of stay down. I'm going to blabber, This next one, you distribute the negative 3, get those answers for that matrix. Just double checking my math as I do this. I think I made a mistake in the other hours, like I said. Distribute the 7. And that gets distributed into all components. Double checking my math. Then after you distribute, you add the equal corresponding components, or the corresponding components. They're not necessarily equal. Bad term. So that's where I get negative 15. That's where I get negative 8. That's where I get negative 68. That's where I get negative 26, negative 38, and 4. Now this gets weird. It talks about taking A, you should do exactly what I'm doing right now, times B, and the possibilities of actually doing that. How is a matrix name? What by what? its dimensions? Rows by columns. This is why you have to really focus on that. And I'm not putting specific numbers here. Let's say rows by columns times rows by columns, A times B. Now, this can't be discovered. I guess it could be discovered. Now, I don't know. I don't even know. It's just such a weird thing. And again, whoever made up matrices decided to make up this is how they multiply them. By the way, though, what's behind it? If you guys remember from Algebra 2, your math teacher hopefully told you that companies can put their data in matrix form, where the row means something. Like the row means New York, and then the column means TVs, next column is sofas, next column is radiators, I don't know. So company sells TVs, sofas, and radiators, and this is the one that comes out of New York. Then the next row is Detroit, same thing. What did I say? TVs, sofas, radiators, and the amount that they have in inventory. That's a 2 by 3 matrix. 2 cities, the rows, 3 columns, the items they sell. And then you could take that and multiply it by the amount you make on each of those items. And then when you take these 2 matrices and multiply them, that's how much money you collect for each of the items. That's how it works in the real world, and it's much more complicated than that, and it's probably done by a computer. But there are matrices involved in computer programming. I guarantee you that. And you could call me a liar. You might be right, but I'm sure someone still does organize their data that way. So, here's the animal. This is all I can tell you. I'm just going to shove it right at you, and you're going to have to memorize it. And after a few examples, it'll sink in. The columns of the first matrix must equal the rows of the second matrix for you to even be able to multiply these matrices. So if you read this, 2 matrices, A and B, can be multiplied if and only if the number of columns in matrix A is equal to the number of rows in the second matrix B. So, I'm going to start this sentence, and I should start picking it, but usually when I tape, I try not, it's hard to pick on students. So, hopefully that's okay. Let's say I have matrix 2 by 3. Those are the dimensions. First things first, you better darn well that matrix B has to have what as its first number? 3, or else you cannot proceed. The rows of the second must equal the columns of the first. The columns of the first must equal the rows of the second. I'm going to call this a 3 by 4. Now this actually talks about what are the dimensions of the answer. Does anyone remember from Algebra 2 what the dimensions of the answer will be? Anyone? 2 by 4 is correct. So, what they try to say is matrix A is an M by N, and matrix B is an N by P. That means these are equal, same letter. That means the dimensions of the answer will be an M by P. That's just putting it in formula form so you can be confused with letters instead of numbers. All right? Isn't that nice? Silence! Can I? This first one, take this matrix times this matrix in this order. What? Yes? What is the dimensions of the answer? Everyone's helping you. Everyone else be quiet. Okay? Next one. Can I or not? No. So this is not possible. You don't have to keep writing dimension mismatch. I'm just telling you what your calculator will spit out. Next one. Yes or no? Yeah. And then what are the dimensions? Silence everyone else. 2 by 3. And then I think this is getting redundant. Everyone yes or no in the next one? Yes. What are the dimensions? And then the last one, yes or no. And then you don't even know why. If you've never done it before, you have no reason why. You're just following a pattern that you're just told by your teacher. All right? But we're going to check this as we go to the next ones to make sure you know what you're doing. All right? So here's the weird animal. Here's how it works. I'm going to zoom in on this so I can write this in a little bit better than I was writing the other hours. So this is why. This is how it works, but it's really not going to show in this one either. It's going to show when we actually do examples. When you multiply matrices, again, I'm just the informant. There is no why to this. It just is. And you got to solidify it, learn it, memorize it, and move on. The first matrix, you select the rows. The second matrix, you select the columns. And you multiply the row by the column the following way. So by the way, what row did I select in the first one? No, which row is it called? Number. Number 1, what column did I select first? So this is the first row, first column. That's where I'm going to put my math in my answer matrix, the first row, first column. And what you do, algebra 2ers, who do I take A times? E is right. Then what do I do? Add it to who? B times G. Now you have to understand that's going to be one number when you're done. You will have one number in row 1, column 1. Then you take row 1 and multiply it by column 2. And put that in row 1, column 2 for your answer. Who do you think A gets multiplied by? F. Who do you think B gets multiplied by? Then you math 2 and 3ers. You're learning a little bit about matrices. You're going to college. If you see a matrix, at least it won't be brand new to you. Who hasn't played now? Who hasn't played the game? CD, which is row 2. I'm going to take that row 2 and multiply it by column 1. I don't know how to write that. I'm just saying, fumble. Row 2, column 1 is where you put your answer. Do you see that? You always got to be aware, right? Your surroundings. C times who? Oh, C times who? E plus who? D times G. First row, first column, C times E. Those are the first in each one of those. Having fun? And then the last one is C times F plus D times H. You'll have 1, 2, 3, 4 numbers. A 2 by 2 times a 2 by 2 can happen. A 2 by 2 is the result. All right. So let's move on. All righty then. Now we're going to talk to our middle group. First of all, oh yeah, it's you. Snuck up on you. What's the dimensions of the first one? This is easy. What's the next one? Okay, so you're allowed to move on. Tell me, who does 1 get multiplied by? Then what do I do? What do I do? Well, what do I do with 4 times 9 and 1 times 5? Plus. Next one. 5. What do I do next? Nope. Good. 1 times negative 7, I'll put in parenthesis form. Plus, right? Good. Just want to make sure. Next. Ah! Give you a hint. Good. It is 3 times 5. Just want to make sure you know where to locate your numbers. Plus, I'll give you that part. See, at this point, what I should do is erase and then circle the ones that we're doing, because that's why the notes get tough. Like erase what we did, and then what we just did is this times this. That is row 2, column 1. Then I should erase this and then see if this person's paying attention, which they are. I bet you they're eligible. So what's the last thing we have to write? Come on. No time. Oh, wait, what? There we go. He's in his own thing. He's actually doing the notes himself. But 3 times plus. All right, and then we'll offline get those answers. You know, when I write the final answer, we had a 2 by 2 times a 2 by 2. We could, and the answer is going to be a 2 by 2. And we already probably see that. Okay, they helped me. A 2 by 2. Now it's going to get wild. Next in this group here. All right, you're the professional. You said you know this, right? What are the dimensions of the first matrix? Careful, this can't get messed up. It's a little weird. It is a 1 by 4. What a strange matrix. It's going to get real weird what happens with this one. What's the next set of dimensions? It is a 4 by 1. May I proceed? Yes or no? Yes. Now, how do we do it? You start it. How do you actually by the way, what are the dimensions of the answer? What is a 1 by 1, everybody? How many numbers is that? It's just 1. This is wild. I could probably try to equate this to the example that I used about the company, but then there's negative numbers in here. You know, maybe the company sells sofas, chairs, I don't know, a podium, I'm just looking around the room, and a poster. And then these are the prices for those 4 things. When you multiply those prices times those items, they match up, the price for each item, and then the final number is how much money you take in. Okay, but anyway, how does it start? Go ahead. 4, what? Next, let's piggyback off here. What do we do? What about negative 3 times 2? What do I got to do with the previous thing? See, that's why we got to understand we're getting one number. We're doing a series of multiply, then add, because that's what we got. We got to keep the string going. I'm not going to bother them anymore. They know what they're doing. Negative 3 times 2. 2 times negative 5. 7 times negative 1. And then that is why, what happened behind me? Someone's laughing. Math is not funny. So something happened. All right? What's the answer? Did anyone actually multiply them? All right, let's move on. He's dying back here. Dying. Okay? Now, oh, these people are pushing papers. That's anarchy. I saw it. Holy. Okay. Now, here we go. Shh. It's a zoo in here. Hold on. I won't even bother you. Leave you alone. How many? What's the dimensions of this one, everybody? 2 by 4. What's the dimensions of this one? Can we proceed? Well, according to what you said, no. But this is why. You have to take this row times this column. Who would you multiply 1 by? Answer it. Who would you multiply 4 by? What doesn't 5 have? 5 doesn't have a friend like Mr. Samulus. So since 5 and also negative 2 don't have a number, this is called not possible. Same error would be told on your calculator. It's because it's a dimension mismatch for matrix multiplication. So there's different things that happen. All right, and then the last one you can do on your own, and then I'll just share the answer. By the way, what is the dimensions of this? 3 by 3. What's the dimensions of this? It is 3. May I proceed? What are the dimensions of the answer? 3 by 1. You should double check that before you go on. Offline, we'll actually do it, and then you'll see the. And then 10 times 0. And then one more. I'm almost done. 0 times negative 5. 7 times 4. Is that 28? And then 0. And then actually get the numbers. Real quick. 19. Negative 53. And then 28. I think that's right. I had to rush.